Welcome back, I'm Bill. In our last video we looked at the Canadian Coleman Company's Easi-Lite suitcase stoves, the 431, 432, and 433 series. In this video we'll be looking at the Easi-Lite lanterns, the 321 series, which you see in the front here, the 621 series that you see in the back, the 331 lantern, which was made just for a short period in the mid to late 70s, is included in this, as well as these 505 series or Peak 1 backpacking stoves. They use the same valves as the lanterns. So we're going to look at these today. This lineup was introduced with the 321 in 1973. The 331 and the 621, the larger version, came out in 1974. The 321s and the 331 are all 300 candle power lanterns. The 621 is 550 candle power. It's a retina scorcher. They're very bright. They're wonderful lanterns, but they are a bit of a mystery to many people. The valves are not as simple as the old Easi-Lite valves, where you simply unscrewed a brass valve stem and then screwed it back in to open and close the valve. They had a tip cleaner usually on the back for the generator. These integrated all of that into one knob. So these, rather than rotating many times like the old brass valves, these have the valve stems are also brass, but they go through the full range from closed or off to clean to light to run, all in 270 degrees. So these rely on a combination of eccentric blocks that engage with the end of that valve stem to raise and lower the generator cleaning needle, and some kind of eccentric block. Some of them have more than one to push down on a Schrader valve or something very much like a Schrader valve, depending on the version, to open and close the fuel flow. So they can be complicated. Most of these are relatively easy to understand, to take apart, to put back together once you understand them, but some of them are more difficult, they're more complicated. Some of these, as we'll see later, you don't want to take them any further apart than you absolutely have to. So you'll notice these are all based on the design introduced with the 335 Easi-Lite in 1970. In fact, most of the parts from the neck up, or all of the parts from the neck up, are interchangeable. And from the neck down, the main difference is, of course, the valves themselves. And rather than having the valve bung in the center top of the fount, they're offset toward one side. But other than that, these are virtually identical functionally to the 335. They simply use this Easi-Lite valve that apparently Coleman thought would be easier to use or less problematic. The problem with these is that they're full of O-rings that are prone to going bad. So one of the things you'll find on some of these, especially the 321, 621, and 321A, 621A, is you'll find the valve knobs or the control knobs are scorched. And that's because there's an O-ring on the valve stem that keeps fuel from running out. And those O-rings go bad and it leaks fuel, which can cause a fire out here. But they can also leak air back in. So you know you've got bad O-rings on one of these if they won't burn properly. One thing to always try, you remember from the other theory of operation videos, to have flame you need fuel and you need oxygen. These are just as prone to having critters like spiders crawl up into the air tubes and build nests or webs, and that can obstruct airflow, so that's always something to check. Run a brush up through the air tubes to make sure there are no obstructions. But usually on these it's because the O-ring on the valve stem is leaking air back into the fuel line. The other issue is that the O-rings or the Schrader valves that are the fuel shutoff or fuel seal point can often fail, or I've had these where the Schrader valve gets a little bit of debris stuck in it and it won't close all the way. So you'll find you may have a fuel leak after you pump it up before you even light it, or you may not notice that and you light it, and then when you go to shut it down, it simply won't shut off all the way. So I'll show you what to do about that. We'll come back in a minute. I'll get all this cleared off and we'll get ready to tear into one. All right, we'll start our look with this model 321, made in 1973. We'll begin by removing the bail. It's simply spring-loaded and we take it off. Quite most of this, if you're familiar with a 335, will be the same. About the only difference is that this is blue instead of green. We'll take the vent off and the globe. And we've got a 7/16 nut here, again just like on the 335. We'll leave that here on the base plate so it doesn't get lost. We'll slide it off. You'll note there are two holes here, again like on the 335. There's a large one for the generator nut and there's a small one for this stud. Now here's where it gets a little bit different on the Easi-Lites. The valve is off-center. That's what this stud is here for in the middle. The stud is what's used to secure the top half to the lower half. Remove that. And while we're at this point, we'll go ahead and remove the generator. Loosen that. Unhook it, set it aside. Now, before we go any further, notice most of these Easi-Lite parts are interchangeable. For example, the only difference between a 321A and a 621A valve is the length of the fuel pickup tube. The 621A has a deeper fount, so it needs a longer tube. The same goes for the 321B and the 621B, or the 321C or the 621C. But one thing that's different between the original versions and the A revisions, and then everything from the B on, is the depth of the valve, or the length of the valve body. You'll notice on this 321C, it's much shorter than it is on these, and that's because the originals and the A revisions have this pop-out, or this projection on the collar. From the B on, it's just a simple round collar. So, that's one thing that's not interchangeable on these. You can interchange the valves. This valve will work just fine on this lantern, but you'll have to swap out the collar as well, because this valve will not project out through the collar. So to get the collar off on the 321 and the 321A, we'll need to remove this screw in the middle here. And the knob should just pull off. Set those aside. Set the collar aside. Now, you'll notice on the 321 and 621, the others don't have them, but there's a jam nut down here. Once the valve is in place, you can cinch down on that just to make sure it's tight. We don't need to do anything to take it off. Before we go any further, let's talk about this valve. On all of these, one of the things that's prone to fail is that there's an O-ring on this valve stem back here. Those O-rings, when they go bad, cause two things. One, they cause air to enter the valve, and that throws off your fuel and air ratio, and the lantern won't burn properly. The other problem is they'll let fuel leak out. In fact, oftentimes on these knobs, the 321, 621, and the 321A, 621A seem to be particularly prone to this. You'll often find blackened burn marks or even melted knobs where fuel leaked out. Sometimes it's just a matter of tweaking it to the left or right or up or down and it'll leak. If that's the case, you'll need to replace the O-ring. Oftentimes that's the only repair these valves will need. You only need to get it to this point. You can put it, and this is the same for all of them. Take a 1/2 inch wrench and remove this retainer nut, or on the B and later, these spring-loaded clips do the same job. Unscrew this. And set it aside. Behind it sits this spring stop, or stop clip, that's what the knob makes the knob click and prevents it from going too far. Now, all we need to do is take pliers and grab this valve stem and pull it out. there's a 009 size O-ring on here. Coleman originally used fluorosilicone, which is a blue-green color. This is Viton. I've replaced this. Fluorosilicone, we think Coleman used that because it's good at very low temperatures. What fluorosilicone is not that great at is in moving parts. It wears out. Viton is actually designed to be both fuel resistant and for moving applications. So unless you're going to be using your lantern or stove in sub-zero temperatures, you're probably best off going with Viton replacements. And you can buy them at an auto parts store. That's where I get mine. They're quite inexpensive. When you're done, once you've replaced that O-ring, all you have to do is put this back in and rotate it. There you go, you heard it snap until it snaps back into the eccentric block. And you can rotate it back and forth. When you see the block going up and down like this, you know it's seated properly. So we'll take that back out. Let's take the valve out. On these, a nice big crescent wrench works quite well. There we go. So you've got the valve body itself. There's a jam nut here. There's some thread sealant on there. I'll clean off the excess. Now, at this point, this nub on the valve stem interfaces with the compound eccentric block set up inside here. Normally, when it's in place, it locks them down so they won't fall out. And normally, on the 621 and 321 valve, these are captive. I'm not sure if they made it this way from the factory or if it's the generator nut being cinched down that causes it, but usually the top of this valve opening is too small, just by a tiny bit to keep these eccentric blocks from coming out. They'll be captive in there. Careful with these. I reamed this out with a drill bit just so I could get these out for illustration purposes. So you've got two of them. They sit in here. I know collectors want to take these apart and polish everything and make sure it's spick and span and run a brush through there, whatever. On this, you won't be able to, not unless you ream this out, because they're captive. There isn't really anything to go wrong in there as long as these don't break. The one caution I will give you, if you're trying to get these out and they're stuck, don't grab the tabs with pliers, like this, and try to wiggle it out. It's very easy to break these tabs off, and you don't want to do that. You'll trash it. The valve is pretty much toast at that point. You can't get new parts for these, so the only thing you can do at that point is to try to find a donor valve from a junk lantern. This upper eccentric block connects to the hook on the cleaning needle in the generator, and as you rotate the valve stem, that little nub makes it go up and down. This lower eccentric block is pushed down once you get to the lighting position. As this nub rotates this direction, it pushes that down, and it pushes this plunger, this air wire, down. So let's see what's going on there. This is a fuel and air tube. It's not very different from the old instant light lanterns. So there's the valve body. What you'll find, you really can't see it without a small light, but there's a seat in there. And that's a seat for this Schrader valve. If you look on here, there's a little tiny rubber seal, and that's the fuel seal point. So this lower eccentric block moves up and down with the valve stem, and when it's in the lower position, it pushes this plunger down. It's spring-loaded. You can see the spring on here. It pushes that down, and it breaks this seal from its mating point up in the valve, and that's what allows fuel to flow. Now, the other way this works, or the other side of it, is it works like the old instant light circuit.
when it's pushed down and in the lighting position, the plunger just barely protrudes through the fuel pickup orifice. It blocks it, but not entirely. So that allows a tiny bit of fuel to trickle in there. And in the lighting position, once the valve is open, what that means is the air that you've pumped into the top of the fount wants to escape. So there are little air holes at the top of this tube. Air rushes in there, down the outside of the tube, picks up fuel down at the bottom, leaking around this plunger, and then it runs up the inner tube into the valve, into the generator. And those little droplets it forms are enough to light the lantern, but not enough for it to flood. So you'll get a flame that will flare up just a little bit, but it's controlled, and that will heat the generator. Once the generator is hot, you move this to the lighting position. Now, on the instant light lanterns, the lighting position allows the plunger to retract, and this opens entirely. On the instant light, the lighting position actually pushes the plunger down further, and it exposes a notch. And that notch allows for fuel to pass freely into that tube. So if we take this out, you might be able to see that notch if I rotate this just right. That notch protrudes through the hole, and that's what lets the fuel out. So these are the components from the 321 and 621 valve. Let's take a look at an exploded diagram. Again, the one thing you'll want to take note of is that 009 O-ring on the valve stem. And note the Schrader valve, that seal point, I am unaware of any way to replace that if it goes bad. If the rubber is bad, I haven't found any kind of a replacement. If it's bad, you'll probably have to find a donor lantern. The one point where it fails, I've never seen one fail, but in terms of the seal, but the one thing that can go wrong is if you've got debris in your fuel or in your fount. It can clog this, and it may keep it from sealing properly. So what happens is you'll start pumping the lantern up, and you'll get fuel leaking out of the generator, or you'll light it and shut it off, and it won't completely shut off. That can be rather dangerous. So that would be one reason why you may want to take this apart. So that's our 621 and 321 valve. Again, the only difference between them is the 621 valve, this tube and this plunger are longer so that they reach to the bottom of that deep fount. So it goes back together the same way it came apart. There's no requirement, no need for thread sealant on this fuel and air tube. I'm going to cinch it down, but it doesn't need to be super tight. Now to get the eccentric blocks back in, you want the tab on the lower block facing the valve stem. So the easiest way to do that I found is to hold the valve so that that's pointed down. Take the eccentric block with that tab on the downside, and then drop it in. And you'll see there are 4 little notches in there. So once it's in, it'll seat itself properly. And then you want to make sure that this notch where the valve stem seats is facing the valve stem. So that you can just drop back in. The valve stem goes in. All right, and turn it to make sure everything's working right, to make sure the plunger, something's not seated right here. I can tell because the valve stem is doing its thing, but the plunger is not. Let's drop those pieces out again. Let's try it again. There we go. I think I may actually have put that lower eccentric block in upside down. All right, there I heard it click twice, which means it's seated with both. The upper eccentric block is working, and so is the lower one now. That's good. Put the clip back on, and the retainer nut, and our 1/2-inch wrench. We'll cinch this up. Now, you need to put some pressure on it. When you do this, don't leverage the fuel and air tube or you'll snap it off. it's brass, it's brittle, or it easily breaks. Ask me how I know. Now, before we put this back in the fount, let's put some thread sealant on here. We'll just make sure that it seals properly, and it'll give us a little bit of play when we try to caulk it right. As if these have been taken out more than once. Sometimes they don't tighten as much as they once did. All of these are caulked properly. That's as far as it's going to go. We need to back it off a little bit. All of these are caulked properly when the valve stem is centered on the Coleman logo, assuming the decal's on straight. I've got one that isn't, so you have to keep a watch on that. So, putting it back together is as simple as what we did before. We'll put the stud in. The collar needs to go on before the knob. The knob locks it in place. Put the screw in. Now, putting the generator on, I'm going to damage the needle on this. And it was bent recently and I had to straighten it. So I'm going to take the gas tip off when I install this. And that'll ensure that the needle doesn't get crushed. When I'm done, I can put the valve tip back on. So we've got the generator hooked on there. Tighten that nut. And we'll raise the cleaning needle, and we see that it's not bent, everything looks good there. So I will put the gas tip back on. If you're ever worried about your generator, if you feel any resistance, take the tip off when you put it back on and replace the tip once the nut is secured. Remember, the big hole is for the generator nut, the little hole is for that stud. Lined up so that it seats on the generator. Now on the 321 and 321A, there are two tabs on the base plate. They need to sit behind this. And once we've got it seated properly, just put that nut on. Again, 7/16. Tighten it up. Globe, bent, and bailed. And she's all back together. Now, let's look at these other valves. This is a 321A. Again, the 621A is the same, it just has a longer pickup tube. The founts are identical. The 621A and the 321A, this is one you do not want to take apart unless there's a problem with it. Again, the valve stem, half inch, this has a 009. Got a 009 O-ring on it. It pulls out and goes back in the same way. Pull it out to put a new O-ring on and then just push it it's aligned. Now on this, the eccentric blocks are cut a little bit differently. They will not come out through the top. They come out through the bottom. The fuel seat is on the 321, the fuel seat is up inside here. It's different on these. So I'm not going to take this apart any further because it's not broken. And taking it apart further will just cause headaches. So we'll put this back together, and I'll take another one that's from a donor lantern that's got some issues. And we'll have a look at it. All right, these are the same, both from the 321A. If you go to take one of these apart, again, if it ain't broke, don't fix it, and I'll show you why here in a minute. This has thread sealant on it. When you put it back together, you must use thread sealant because this doesn't thread all the way up until the threads are tight. So you may have trouble getting this off. The thread sealant Coleman used will make it very tight. And just taking it off, you've already got one headache putting it back together from this point. And I'll show you that in a minute. Now, what you've got here, instead of the plunger that sits up here in the 621 and 321 that seals inside the valve body, you actually have a Schrader valve right here at the top of the fuel and air tube. That's what this plunger is. The eccentric blocks in this valve are exactly the same as the other one. So when you open the valve, it pushes down, the eccentric block pushes down on this plunger. It opens the Schrader valve, which is right here, and you'll see it also actuates the air wire the same way. So here it's in the lighting position, it blocks the hole, and then when you put it in the run position, that notch appears, allowing an unrestricted flow of fuel. So you may have some reason to take this apart at this point. Maybe for some reason you've got to clean those eccentric blocks out, and they will drop out the bottom as soon as you remove this. They aren't captive in there like they are on the other one. You may have, if this was sitting in fuel for a long time, it may have green or brown gunk all over it, and that hole may be plugged. Before you take it apart any further, before you even take it apart this far, see if you can boil it out in vinegar or citric acid. See if you can spray carburetor cleaner through there to try to get it cleaned out, because you don't want to take it apart any further if you don't have to. Now, what's inside here, you take some needle nose pliers. Whereas the other one had that Schrader valve that's a little non-traditional. This actually has more or less a standard Schrader valve in it. The only difference between this and other standard Schrader valves is they usually have a nub on the top. Now, this Schrader valve normally will not come out this easily. Normally, if you unscrew it, this top part will come out, and this will be stuck in there. It's not terrible. You can put them back together like this, and it'll probably be okay. The problem is getting the rest of the Schrader valve out. This rubber seal sticks inside there, and you can pull and pull and pull, and it will not come out. It requires heat to loosen it up. Now, I've heard some people have had some luck boiling this for 5 or 10 minutes in water, and that was enough that they could then tug on the plunger and pull it out. Didn't work for me. The only way I found, and I've talked to a few other guys who've taken these apart, is to go ahead and unscrew the threaded top part that holds it in, take that out, and then you'll have this part stuck in here. Pinch this lightly in a bench vise so that it's standing upright and that you can tug on the plunger. Take a propane torch and heat this area evenly all around, and just barely heat it. Try to do that with one hand, and have some pliers on the plunger with the other, and tug on it, and heat it only just enough that it pulls free. You might not damage it. I'd say there's about a 50-50 chance, based on my experience, that you'll end up cooking the seal. and once the seal's cooked, it's no good. So if you have to replace this, and there's a good chance you will if you take it apart, that's why just try to clean it in place if you can. Take it down to an auto parts store. I went down to Napa. They brought out a whole kit with all sorts of different Schrader valves in it, and we looked up one on the chart that was fuel resistant, and it just happened to be the right length, so it worked. I'm told that the Schrader valves used in Ford fuel rails are just the right kind and the right size as well. And someone said the problem is they come in a kit, and they aren't available for customers. But maybe if you buy a beer for a Ford mechanic, they might be able to give you one. I wasn't that lucky. If you buy a replacement, chances are it's going to have a nub on top. That nub will restrict the full motion of the plunger. This plunger needs to be able to go all the way down. So what you'll have to do is remove that nub. Don't snip it off because you need the full length here. Don't reduce the length. Take a file or take sandpaper. Even someone told me they used a bench grinder. I don't have hands good enough for that. But I simply put 220 grit sandpaper on the edge of my table, and I sanded it and on the edge of the table and rotated as I did it until the nub was gone. And then I pressed on it multiple times to make sure it went flush all the way and it didn't hang up. And I replaced it that way. But ideally you don't want to have to do that. The Schrader valves really shouldn't go bad. The reason it would go bad is because you took it out when you didn't need to, or you took it out to clean something in here. So try to clean it some other way first. So you put the Schrader valve back in, or hopefully didn't take it out to begin with. Now, when you put this back, you can't just tighten it all the way. If you do, it'll go in too far, it'll hit the bottom eccentric block, and it'll force the Schrader valve open. What you want to do is, when you're screwing this back on, ideally what you can do is turn the valve all the way to the full on position. You want to it'd be easier to put the knob on here so it hits this stop. And then you want to screw the fuel and air tube on. Screw it on until it's snug. What this is doing is it's pushing that lower eccentric block to its bottom position, and then you screw this in until it bottoms out, and you should see that the notch is just barely exposed through the hole. That's what you want when it's in the open position. Now, once you've done that, you can turn it back to the lighting position. The Schrader valve should still be open, but the hole should be blocked. And then if you turn it back to the closed position, it should still be blocked as well. The Schrader valve should be closed. At this point, once it appears that everything is situated properly in there, you can put it back in the fount, tighten it down, put some gasoline in, make sure that it's closed. You'll want to have the knob on here when you're doing this testing. Make sure it's closed, and then pump it up. Grab a paper towel or a Kleenex. As you pump it up, keep an eye on the generator, because if the fuel and air tube isn't positioned properly, if it's up too high, it may be bottoming out already against that lower eccentric block. So pump it up, make sure there's no fuel leaking, put your ear down, make sure that there's no air hissing. Wiggle this knob a little bit, push it up, because that pushes the bottom down, and if it's very close, that may be enough to open the Schrader valve just a bit. So if it leaks at all, unscrew it, take it back out, and back this fuel and air tube off just maybe a quarter or a third of a turn, and then put it back in, pump it up, and test it again. Now once you know that it's really sealed when it's in the off position, get the paper towel ready, hold it over the top, and move it to the light position. Now it should sputter just a little bit, and you should have some fuel splattering out of the end of the generator. That means it's good. So now turn it all the way to the full open position, to the run position, Again, have that paper towel handy over the top to catch the fuel, and you should get a nice good stream coming out. If that doesn't happen, you need to take it out, and you need to either back it off or tighten it up just enough so that all of this is working properly. So you get a stream of fuel in the open position, a sputter in the light position when it snaps into that position, and no leaks when it's off. So that's the 321A and 621A. I'll add the original 505 stove also has a very similar valve design with that Schrader valve. Again, 505, you don't want to take it apart if you don't have to. Now, let's look at, before we move on, to the 321A and 621A. Here's that valve. Again, you've got that 009 O-ring. Important to know if you need to replace that. But the big difference with it is it uses a more or less off-the-shelf Schrader valve mounted in the top of the air tube. So now let's move on to the second version. This is the 321B. Take the valve out. This is found in the 321B. It's found in the 621B. It's also found in the 331. And it's found in the 222. The 222 is the original little backpacking lantern, often referred to under the brand name Peak 1, just like the 505 stove. They all use this valve design. So the first thing you'll notice is instead of having a retainer nut, they have this retainer clip, and it fits over these serrations. So we need to take that off first. It can be a little bit difficult. You've got to work it over some of these and then hold it there, roll it over and work it over some more, and sometimes it wants to go back on the other side where it was. You'll notice it's got the same triangular block on the side or stop. Now, valve stem, shorter, but it's the same as the others. Again, 009 O-ring, it's got that same nub that interfaces with the eccentric block in here. We'll take the fuel and air tube off. Now I found some of these have thread locker on them and some don't. If they do, they can be a real bear to get unscrewed, but they will come apart. It's a fuel and air tube, not much different from the others. It does thread in differently. It threads in up here, it's got a bigger thread. We've got our valve body. Now here's where the difference lies. It's got a simple eccentric block instead of a two-piece one. The air wire, or the plunger, is attached to the eccentric block. And again, you can see, I'll try to rotate it so you can see, it's got the same notch down here at the bottom. So functionally it works the same way. But here you've got, instead of a Schrader valve, in a sense, this is a kind of a Schrader valve, but instead you've got an O-ring here. This is an 007 O-ring, and it fits into a seat up here inside the body. In fact, you can feel it sort of, it almost snaps into place. So the valve stem rotates, it in the down position, it pushes it down, that opens the flow of fuel. And in the lighting position, that plunger just barely plugs the hole, and then in the run position, the notch is exposed. So in that case, it works like the others. This one's much easier to work with, not much to be afraid of here. So we'll put that back together. And it's meshed. Shouldn't need thread locker, even if it had some on there to begin with. And put the clip back on. So that's a 321B, 621B, 222, 331. and the 505A stove. Now, this gets a little different, although it looks the same on the outside. This is a 321C. This is the valve used in the 321D. I'll come back to the 621D. Did I say 321D? I meant the 621D. 321C, 621D. We'll come back to the 621C in a minute. This is also used in the 222A. It's used in the 325 and the 625 lanterns. The 325A and 625A have a similar design, although they've gone back to a compound eccentric block in those. But at this point, this looks exactly like the 321B. If we turn it over, the one thing we notice is that on the bottom of the fuel and air tube now, there's an opening there that's recessed. In fact, you can't actually see the fuel pickup orifice. It's down in that dark well. That's the one change we can see so far. So again, fuel clip, or the retainer clip comes off just like the other one. Work the top off, work the bottom off, work the top off, work the bottom off, and eventually it'll all come off. Almost there. The valve stem, again, same 009 O-ring. Again, these sometimes have thread lockers, sometimes they don't. This is the fuel and air tube. We take that off. Ho-ho! This is different. It looked the same on the outside, but it's different inside. Notice there's no air wire, there's no plunger. This is an 005 O-ring. That's the fuel, the fuel seat point. It snaps into the top of the fuel and air tube, then when the valve is turned, it's lifted up and out, or the valve stem is turned, it's lifted up and out, which opens the flow of fuel. But there is no air wire or plunger blocking that hole in the bottom for the lighting feature. You'll notice this is the collar from a 621C. There's no lighting function on it. It's off, it's got clean, and it's got run. And if we were to look at a 325 or a 625, which uses the same valve, they've got degradations in here, gradations. So it's from full strength to a dimmer light. And what have they done? They've actually done here is gone back to a very early design from about 1930s. Instead of having the plunger in here to partially plug that hole, what they've done is they've put a much smaller hole in here. In fact, on the old 220s and 228s, they use a generator tip, and it's only an 0.008 of an inch in diameter. So very, very little fuel can pass through there. So what happens, instead of having a special lighting position, you simply open the valve, and when the generator's cold, there's no back pressure to restrict the flow through. So what happens is, you open the valve by lifting this plunger out. Now it's open. There's no restriction. So a little bit of fuel is going to run in there, but the path of least resistance is for the air pumped into the top of the fountain that's under pressure to enter through this hole, flow down the outside tube, up the inside tube to the valve, and pick up a little bit of fuel from there. That's what you use to light the lantern. It causes a bit of a flare, but not much. It's controlled, and it'll heat up the generator. And once the generator's hot and you've got expanding fuel in it, it builds up pressure. That pressure puts pressure back on the fuel system, and what that does is it ends up cutting off the flow of air here, and instead the fuel follows the path of least resistance through that hole, and there's just enough fuel to get it running, or to keep it running. So, very different design. On the 325A and the 625A, it uses something similar. It's got a compound eccentric block in it, and it uses the modern plastic fuel and air tube that you'll see in the current lanterns made in Wichita, but it's basically doing the same thing. So that's the 321 and 621 valve, again used on the, I believe, the 505B and (222A). Together just like that. See, someone had some trouble getting this off at one point because it had a thread locker on it. So let's look at some of these again, some of the exploded diagrams. Here we've got the 321B, and you see it's got this simple eccentric block, but it's still got that air wire on it that's used for the lighting circuit. And now here's the later version of the valve. This is basically the final version from the 321C and the 621D, the 325 and 625. It's got a very similar eccentric block. The fuel seal point is very similar. It's got an O-ring. In this case, it blocks the fuel in the top of the fuel and air tube. But now there's no air wire. It just doesn't work that way. They rely on a smaller fuel orifice in the bottom of the tube to restrict the flow during the lighting. Now, let's look finally at the 621C. I don't have an actual valve to show you. Special thanks to Roland Chevalier for providing this exploded diagram from a presentation he made several years ago. The 621C, not the easiest lantern to find, and in large measure that is because they look just like a 621B. In fact, the collars say 621B on them. They seem to have been some kind of a transitional model. The only place you'll see the mark 621C is on the box. So the way to identify them without the box is if it says 621B, flip it over. If the manufacturing date is in 1982, that's actually a 621C. And if you take the valve apart, you'll find this inside of it as opposed to the 621B valve. It's very similar. In fact, this would have been the design that predated the 621B and 321B valve, or rather the 321C and the 621B, sorry. But it's very similar. Again, there's no air wire. It doesn't rely on that. It's simply got that small, tiny hole at the bottom of the air tube. But the fuel seal point is a little bit different on these, and that's the one that sometimes throws people. It's also in the top of the air stem, or air tube. There's an O-ring that fits in there. And then to hold the O-ring in place, there's a washer. And that washer is basically loose until you put the eccentric block in place. And the eccentric block has a profile tip that slides in and out of that O-ring when you turn the valve stem. And that's the fuel shutoff. Other than that, it's the same as the valve in the 321C. So that's the 321, 621, 222, 331, as well as the 505 stove lineup. Those are the valves. I know that these valves can be a real mystery to people, especially the A revisions. Don't take them apart unless you absolutely have to. But I hope other than that, this has demystified them, helped you understand how they work, because they are quite different from the others, and they can be a little frustrating. Once you figure out one, you suddenly realize the others aren't quite the same. So anyhow, that's the Easi-Lites. We'll see you next time. Thanks.